This will be our last video on factoring and solving quadratics for now. So I'm just going to do two more examples that look different than other examples that we've done so we can say that we've looked at as many of the possibilities as possible. The first we had is this. It's 6x squared minus 5x minus 6 is equal to 0. So this is one of those ones that's a little bit different because the value of a is not 1. So what we're going to do here is this. We're going to make this little t-chart here. And we're going to take factors of 6 times negative 6 of negative 36. Those factors have to sum to negative 5. Negative 5. We could do lots of things. One thing is that we know that there are factors of negative 36, and there are two numbers. So one of them's going to be positive, and one of them's going to be negative. And just to skip to it, we could do this. We could do negative 1 times 36. Well, that does equal negative 36. But negative 1 plus 36 does not equal negative 5. We could do negative 2 times 18. You say, well, that does equal negative 36, but negative 2 plus 18 does not equal negative 5. At some point, though, we should start looking for those factors, and hopefully we know a lot of factors of 36. And the two that I came up with, I think, were positive 4 times negative 9, and that is, look, that is negative 36, isn't it? And positive 4 minus 9 is equal to negative 5. So victory here, right? So this comes to the next part, and it's really important that you set this up correctly. What I'm going to do is bring this down here. I'm going to get 6x. I'm going to rebuild this negative 5 a different way. Now what I'm going to do is I'm going to take plus 4x's, because of this 4 here, and minus 9x's. That's because of this negative 9 here, right? Because those are the two numbers that worked, positive 4 and negative 9. That's where I'm getting these values from. Because I'm setting myself up for factor by grouping. So somebody will say, well, how come you don't just combine these two and you'll come up with that? Well, that's where we started. So but what we're trying to do is trying to factor this so we can get a solution. So I'm trying to build this model of factor by grouping. All right. So this is also a really important thing. See this negative sign right here that goes with this negative 9? I'm going to push this over because I do not want to accidentally, when I do this, right? Because I'm going to factor this by grouping. When I do this, I don't want to get the negative sign on the outside. It doesn't belong there, does it? So here, I just want you to stop the video for a second and contemplate this. There's just a positive 1 here, and if I multiply this positive 1 through, nothing happens here. And this is a positive 1 here, and if I multiply this through, nothing happens. But if I had accidentally factored out that negative 9, this negative 9, if I had taken the negative sign out, well, when I factored it back in, the negative 9 would have been fine. But when I factored a negative times this negative, I would have accidentally changed the problem into a positive here. So it's something to think about. Here, let's look at this. So we're going to do factoring now. So we're going to factor this group, and then we're going to factor this group. We factor this group. The greatest common factor of 6 and 4 is 2. The greatest common factor of x squared and x is always the lower of the two values. This is an x squared, this is an x to the first, so x to the first. And then we have to rebuild this, right? So 2x times 3x is 6x squared. 2x times 2 is our 4x, right? Now here, we have to try to figure out what to factor out. Let me say this again as clearly as I can. What we want is when we do the second factor, we would like, in a perfect world, for it to come out to be 3x plus 2. So what am I going to factor out here? Well, this is a negative and this is a negative. If I factor out a negative, what is a negative 3? Negative 3, greatest common factor of 9 and 6 is 3. Then look what happens. Then when I multiply this, 3 times what is negative 9x? 3. That's looking pretty good because what we want is 3x here and 3x here if possible. And negative 3 times what is negative 6? And it's positive 2. Hopefully you can see that worked out really, really good for us, right? What I'm going to do now is take this group. I'm going to cancel one of these. It's not canceling, it's actually simplifying. We'll look at it in just a second because that really bothers people. So here's our 2x. Our negative 3 is here. And then our 3x plus 2 is here. Now, you're going to say, well, what happened to this one? Nothing happened to this one. This is, if we use FOIL, it's 2x times 3x, so 2x times 3x, then it's 2x times positive 2, 2x times positive 2, we didn't lose anything, and then if we use FOIL, it would be negative 3 times 3x, well there it is, negative 3 times 3x, negative 3 times positive 2, negative 3 times positive 2. It's just simplifying it, we're condensing it a little bit. And now from here, we can just solve, can't we? So again, let me remind you, these are our factors. These are our factors, right? Not our solutions. Our solutions come when we start to solve. 2x minus 3 equals 0. And we do simple algebra and we start to solve that. We get 2x equals 3. We divide both sides by 2. And we get x equals 3 halves is one of our answers, isn't it? Our other answer is answered when we answer the question, when is 3x plus 2 equal to 0? We subtract 2 from both sides. We get 3x equals negative 2. And then we're going to divide both sides by 3, and we get x equals negative 2/3. These are the solutions. So solutions and factors. I'm going to try to get through one more problem and try to make it quick. So this problem says this. We have x squared plus 25 is equal to 10x. So we're supposed to solve this. Let's solve this. That means we're going to factor it, and then we're going to come up with the solutions. What numbers make that whole thing equal 0? First thing I'm going to remind you of is that when we see this, when this is the highest exponential value of a variable, then usually we want to put it in this form, bx plus c is equal to 0, and start solving from there. So the first thing I'm going to do is add negative 10x to both sides. So here's our x squared. This positive 25 is this one over here. And if you see, I'm going to put this I'm going to add the negative 10x on this side also. And that negative 10x goes in between. Okay? It just makes it easier for me to see. Now what we want to know is, what are two numbers? When we multiply those two numbers, we get negative 25. But when we add them, we get negative 10. Well, here's something that you should be noticing, that this is a negative and this is a positive. So this first part is easy. X squared, that will be x here and an x here. Why? Because x, if we do FOIL, x times x is x squared, and that's how that's made. But if we multiply two numbers and they're positive, here are the possibilities. If we're going to we could multiply a positive times a positive, and that would certainly be a positive. Or, and think about this, so a positive times a positive is a positive. Or a negative times a negative is also a positive. But a positive plus a positive is a positive. And if we add two negative numbers, we add the numbers and their sign remains the same. So we know that our two numbers are going to be negative. Why? Because a negative times a negative is a positive. How do we know they're not going to both be positives? Because a negative plus another negative has to give us this negative. And what are those numbers? Well, they're 5 and 5, aren't they? Equals 0. So this is a very interesting solution. Because what this gives us is, our solutions here is, when is x minus 5 equal to 0? When x equals 5. And if I do this one, when is this one equal to 0? When x equals 5. So this one only actually has one solution. X equals 5 is our solution here. I also want to remind you that some of your teachers, and I don't blame them at all, if you said x times x, they would say x squared. If you said 5 times 5, they would say 5 squared. And if you say x minus 5 times x minus 5, well, in the same way, that is x minus 5 squared. Hey, next time you see me, ask me if exponents are distributive over addition, because I don't think that they are. Be careful. Good work.